All right, hello everybody. Welcome to the evening on making your Angular app behave. I am here with Fabio and Gert. Maybe you can introduce yourself quickly, Fabio. You're still on mute, though. Yeah.
Oh,
Yeah.
yes. Everybody, welcome. This is the first time that Reactive Amsterdam goes virtual. I have to say the pandemic took us a little bit by storm, and for a community like this that was mostly in real life, there wasn't. I don't know. We didn't. It was a hard change to digest, let's say. But I'm really excited that we're finally starting with this, and so. Yeah, really happy to start this session in collaboration with Adesso and with Hurt and David. Um, and before going into the core of the meetup, I would just like to share with you a couple of slides that I made with some events. And oh, there we are. So there have been a lot of conferences online, as you probably know. And there's one coming that I'm actually really happy about and really looking forward to. In chronological order, the first one is CodeMotion. CodeMotion used to be a pan-European in real life conference. They've done conferences in Spain, the Netherlands, Germany, Italy, and whatnot. But of course, with this situation, what they're doing is they're merging all these sort of local conferences into a big online tech conference, which will be, I think, maybe 3 days, 2 or 3 days. And fun enough, I will be the MC for one of these 3 days. And that also means that I have some free tickets to give away. So in case you're interested, do send me a message. Let me know. I have some, and first come, first served until I run out of them. Check the website, see the speakers if it's something you like. Also, on the 10th of November, the Reactive Summit is back. Last year they skipped it, but the years before, it was always a big success. It was in Montreal in 2018. I was actually a speaker there. And this year is obviously virtual and actually free. Again, check the speakers and the program in general, and I think it's going to be a really worth one. And then finally, actually, by the same organizers of the Reactive Summit, just a couple of days after, there is this conference called Scale by the Bay, for which I have a discount to offer. If you use functional at checkout, you're going to get a 10% discount. And I mean, it's not very expensive in general. Applying the discount, the total will be around 85 euros. So should be pretty affordable. Something to mention about this conference is 2 days, as you can see. It's based in San Francisco. So for us Europeans, the time zone might be an issue, but it has been arranged in a way that the conference starts very early in San Francisco. It starts at around 7, which is sort of afternoon here in Europe, and then it will go on until about midnight European time. So not ideal, but still doable in a sense, still feasible. I'm personally looking forward to all 3 of these conferences, and again, do reach out to me from the Reactive Amsterdam meetup page in case you're interested in a free ticket for the CodeMotion online tech conference. And with this, I'd like to again welcome you all and hand over to David, who represents our partner for tonight, Adesso, and he's going to be giving a little introduction about it.
All right, thank you, Fabio. Before I do that, I would like to add that during the talk, at any time, you can just pop your questions into the comments section here somewhere on YouTube. If you don't have an account on YouTube, you can't enter comments. So we provide the sli.do/reactive-angular, where you can also anonymously enter your questions. So don't hold back, send your questions, and then at the end, we'll address them in the Q&A. All right, so who am I? And what's Adesso? Well, my name is David. I've been a developer since 2005. Started off in the public sector, writing desktop applications in C++, until I rolled into the wondrous world of Java and web development back in 2015. Then in December last year, I joined Adesso Netherlands here in Amsterdam, which is one of the most recent branches of the Adesso group. Now, who or what is Adesso? I hear you think, well, the company was founded back in 1997 and has since grown out to be an international organization with over 4,000 employees across 36 offices in 7 European countries and Turkey. And with the mantra of business, people, technology as a company, we really do value our people and absolutely love technology. There's room for experimentation, and there's a lot of attention going to personal growth and continuous learning. But don't take my word for it. The awards our German colleagues have collected over the last couple of years speak for itself. And here in the Netherlands, we aim to do at least as good. So if you're a developer and looking for a new challenge, make sure to shoot us an email. And of course, if you haven't already, don't forget to join the Reactive Amsterdam and the Adesso communities on Meetup for more great webinars to come. All right, that was it for me. With that all being said, I'd like to introduce my colleague Gerrit Neudert. And yeah, we'll leave the stage to him.
Okay, thanks, David. So yeah, this is also the first time for me giving a talk remotely like this. So it's a new experience. I hope everything will go well. Some initial words to my person. I'm also working for Adesso, but I'm located in Germany, more precisely in Nuremberg. And I'm now nearly 2 years working as a software engineer for Adesso. Before, I was in another company for about 7 years, and I worked in many different projects in the role as a developer, as a front-end architect, also as a product owner. So I consider myself not being limited to certain kinds of technology. I'm always open for new things. As a fun fact, David, I also started with C++ programming, at least when it got more serious with the programming, but that's a long time ago.
Good old MFC by any chance?
Yeah, and well, that should be enough about my person.
Okay.
And with that, I would like to start with the talk. So yes, I'm giving a talk about making your Angular app behave. And well, as we are talking about reactivity, one might start with a question, what is reactivity? And for sure, there are a lot of different definitions for this. You could go over to the Reactive Manifesto and you could discuss all these things, what reactivity is. That's all good and nice, but it's, you can see this as an architect's point of view on the problem. However, from a user's point of view, a reactive program is simply a program that works as expected. And that's actually all I have to say about it at the moment. And reactivity in general is independent from the programming paradigm that is being used. However, reactive programming is a concrete technique. So this is something that I will discuss in this talk. However, I will not start with definitions here. If you look it up, you find a lot of confusing things. I will come back to this later in the talk, and then I actually will give some definitions for this. But for the moment, I only want to mention one important aspect of reactive programming, and that is that it is programming with a declarative mindset. And this aspect, however, is very important, at least for people that currently are working in an imperative mindset. Because for those people, it would require not only learning something new, but also to let go of something old. And letting go of old habits is much, much harder than learning something new. And this is what makes going into real reactive programming a challenge for many programmers that are coming from a completely imperative mindset. So, as you know from the introduction, I will give examples for reactive programming with an example in an Angular application. And for Angular, there are two major good parts, in my opinion. And the one part is that RxJS is first class integrated in Angular. So as those people who are attending this talk likely have a good idea what RxJS is. It's the reactive extensions version for JavaScript. You have the reactive extensions for almost every knowledgeable programming language. So learning it in one language will also benefit you in working with other languages. And however, just using RxJS, so just having it first class in Angular, does not necessarily mean that you are already applying reactive programming, as we will see. And well, TypeScript, of course, is also a nice thing because it just helps you documenting your code and refactoring. So documentation by typing. Well, there are not only good parts, there are also bad parts in Angular, at least with respect to this talk. So when I say bad parts, classes, object orientation, this promotes imperative mindset, I do not mean in general that the object-oriented style with good old object-oriented dependency injection is bad in general. It is just that it clashes a little bit with the whole idea of reactive programming and RxJS. The object-oriented with Java look and feel that Angular has is kind of a selling point for Angular that is attracting a lot of programmers that are coming, for example, from the Java world. And this means that likely many Angular developers also have an imperative mindset. And this finally makes Angular actually a good example to show also some new ways. So preparing this talk, I started a little bit over-ambitiously with some kind of real-world application that I was going to refactor from some code smells to really reactive program. But I quickly found that this was too much mental load for a single talk, and it also would just distract from the important parts. So in the end, and I hope you can forgive me, it's just going to be a boring book search example, but I hope you can still find some new concepts while we're going over this. So let's just start with the requirements for our application. What we want to have is an input where we can query for books. We want to search for books as long as we do not enter an empty query. And we also want to somehow indicate that we are searching so that the application is busy. And we want to display our search results under the input. So finally, this is running live on my computer. So when I type something, I will get some books. I did not use some public real-world API that one could use here for, but instead I just a simple service with some mock-up data. So not a lot of books that we can find here. So as you see, it fulfills all requirements. It should look more or less like this. Let's have a look at the componentry for this simple application. We have a root component, then one smart component, the book search component, and we have two presentational components, one to render the list of books and one for the query input. Well, here we have the input component. As I said, simple presentational component, just input and output. And you can see here, I have no styling, nothing. It's kept to the most simple thing. And this component is not only presentational, it's even does not have any domain knowledge, so you could use it everywhere. Here is our list component. Also very simple. This has just a single input, so just an array of books. And in contrast to the input component, this component at least has domain knowledge because it knows what a book is. Yes. So the more interesting part now is our smart component. So the search component that composes the two other components. We have the input component where we just pass our current query in, and we have an event handler for new queries that the user enters. And then we have the case that the application is loading, where we will just show loading data. And if we are not loading, then we will show the current list of books. So that's actually enough of HTML. We are not really interested in this for this talk. The component itself, it has these three properties: the query, the current books, and the loading state. And of course, we somehow need service to query for our books. And then our logic must be in this event handler where we receive a new query event. So let's look at the three states that we somehow have to cover with our logic. We have a state where we have no query, and in that case, of course, we do not want to show any books, and the application is also not loading. We can have a query, but we do not yet have the books for this query. This means we are in loading state. If we have a query and also the books for this query, then again, we have no loading state. We are showing the result list. So our logic, if for some reason we start with a query that is already the current query, we have nothing to do. In the other case, we just update our current query. And then if it's not an empty query, we have to start loading. So we set the loading to true. And then we ask our book service to find us some books. So here you see the first time RxJS in action. All the HTTP client in Angular by default gives us observables, so we can subscribe to an observable. But of course, we are in no way reactive here. We are subscribing to a stream, yes, but it's a stream that simply sends one value and completes, or it might error. And we are subscribing, and with the subscription, we are breaking our reactivity anyways. And in the end, we are just performing imperative code here. So, by the way, I said the service could also throw. Well, of course, first of all, we have the case where we have no query, then we just set an empty list. But what if our service would throw? Well, as I think most people will know, if you do not catch explicitly in a subscribe block, then the error will just be swallowed. You will see nothing. So there is no error on the console. The user has no idea that there was an error. Nothing happens. It's just swallowed. Therefore, it's always important to handle errors explicitly. So here our error handling also means that we are just setting the book list to empty, and of course we could also show some alert. So I got over this step before. We have here some method where we say that we would update our books, and we will only do this. This is code starting in line 24. If our current query still matches the query that was used to find these books. Because if this is not the case, then the user has already entered another query and we are no longer interested in the results here. And the same is true for this loading state. We only want to set it to false if there is not already a new query running. So finally, now there is a little optimization here, and this is that I added a timeout around this whole block, and this is just for debouncing, because in the initial version, if the user was typing very quickly, then of course we would start a lot of queries to the book service. And with this timeout here, I just used 200 milliseconds. We can debounce this whole query. So directly after the timeout, we are looking, is there meanwhile a new current query or is it still the same? And if there is a new one, then we can return here and wait until the user stops typing quickly. So it works as expected. Well, at least this is the same version that I had in the beginning. Can type quickly. Everything works. So if everything is working, is there a problem with the code, you might ask? Well, not yet, but let's try a few things. We could add we could change our change detection strategy from the default strategy to on push. So let me just apply this in the code. So I have added also this to the code so that you see there is a change now. As you might know, change detection on push means that Angular is no longer polling for any changes in your component when you make any changes. But now it's looking for changes only if an input to the component has changed or if an event handler is evoked in the component. So if you think now that nothing might happen if we're typing, you're not completely right. So if I start, for example, typing an A, nothing happens. This might be the initial guess because we are setting our properties. So we are not changing the input binding. And yeah, as we have now on push change detection strategy, Angular would not have noticed this. But if I now type in N, we suddenly see some results. If I now type something where I know it should find nothing, we still have results. Let me remove it. No longer any results. So what's going on? Well, the explanation is quite simple, actually. we have added this debouncing as a performance optimization. But unfortunately, we did it all wrong. So this set timeout in line 6 is a problem. As I said, the change detection not only kicks in if an input binding changes, but also if an event handler is invoked. And well, here we have an event handler in line number 1. This is the event handler for new queries. So this kicks in the change detection after this event handler finishes. So what we do in line number 5 is that we are setting the current query. Then the change detection is running, and after this, the code inside our timeout is running. We are setting the loading status and we are setting the books, but of course, no change detection is run again. So actually, what we did is even worse than not updating the component, because what we did is we introduced an invalid state. We introduced a state where we are showing results that do not match the query. So we have these 3 valid states out of 8 possible states in our component. And we had all the rules that we needed to code only valid states. And we considered the rules while we coded this, but we simply forget to consider the time. And this brings us to the problem of valid state in an application. If you would have an application that consists of only 20 booleans that could change over time and nothing else, this would already lead to more than 1 million possible states your application could have. Well, since the old jQuery times are over, we hopefully all agree that regardless which framework you're using, it should handle your view just as a function of your state. So in the end, if you ensure that your state is always valid, then at least you can be sure that your view is also always valid. It might not be up to date if you have a problem like the problem at hand where the change detection is not running, but at least it's always valid. Yeah, and the reason that we have this problem that we introduced an invalid state is due to the imperative style of coding. You can identify this style by the fact that there are a lot of ifs and elses in the code. Actually, if you would use a declarative style instead, there are very, very rare cases where you write some if or else condition. So this imperative coding style, it's very error prone. Instead, we should define our dependencies declarative and thereby, and that's the important thing, also explicitly. But first, let's have a look again at our 3 possible valid states. If we look closer at it, then we see that the loading property can actually be made a transient property because it always depends on the current query and the combination of the current result with the query that was used for the result. So let's make just this, and let's transform our code from line 3, where we have loading as a simple Boolean, to a transient getter that now only depends on this current query and the query that was used for the results. And let's have a look how this code now behaves. Give me a moment. I have to change it again because this is a live running code. So it should recompile, yes. So now we have both. So first, again, the old on push version that was not working correctly. I do it again. Nothing happens when I type in A. Nothing happens when I type in N. We have a result list, but we know it's the wrong list. So we have a wrong state. Now we have another wrong state. By the way, we have nothing more and we have loading data. Now let me show this in the new version where we made our loading property transient. Now I can type in A and it stays loading. Can type in N and stays loading. Whatever I do now, it stays loading. So the question is, did we gain anything by this change? And I say, yes, we did. Because as I said before, our app is now showing an outdated state, but at least it's a valid state. And that's more important. Well, what could we do about this outdated state? If you're coming with an imperative mindset, we could just say, okay, let's inject a change detection ref and trigger the change detection manually whenever we set any value in this component. And this might sound a little bit crazy, but that's actually what many people will do. They will have this problem and they will ask Google for the on-push problem, and they will get this as a solution. Inject a change detection ref and trigger it manually. Now you might also say, well, why should I not just disable this on-push thing? So why should I not just use the default Angular change detection? Well, as you might also know, if any of the parent components of your component is on push strategy, then your component will be on push strategy too. So you do not always have the choice. And so far, we have a very, very simple application. And yes, it's absolutely possible to handle everything perfect in an imperative style. But as soon as your application is getting just a little bit more complex, things are going really to become difficult. So I admit that this is a little bit an artificial example, but what we would have here, now an application with at least 3 different screens, so a home screen, a book screen, and a movie screen. Here we also have a header component where we can set a query globally, and we need to access our books also from the home screen that is showing them in a table and in a movie table. And you can also think of components that are added to add books or to edit books and that need then to trigger updates. So what we need to do is we need to pull out state from the individual components. So with that, you can say bye-bye to your good old object-oriented data plus behavior encapsulation. And we need some kind of state management and change propagation. And the change propagation will finally bring us to the reactive programming. But before I come to this, I'd like to start with my first point for refactoring an Angular application to reactivity. And this is go into your application and put each and every component you have to on-push strategy. If you read about this in the internet, you will often find this as a performance optimization. Well, that's not wrong, of course. Having on-push strategy gives you the benefit to have better performance because the application is not the whole time polling for changes and rendering unnecessarily. But the major advantage here is that it will show you code smells, problems in your code, problems where you are not treating your data immutably, or where you have no correct change propagation. think back on our initial problem where we used a set timeout. In general, just the fact that you have a component where you use a set timeout is a code smell, because set timeout is an imperative concept. Why are you using it? You are using it to perform some side effect after some time. There is no notion of the when this effect should happen. So yes, the when after a certain time, but not in reaction to anything. So most likely, if you have something like a set timeout, this is a workaround for something not working correctly. So for some missing updates, for example, or whatever. So back to change propagation. Reactive programming expresses dependency declaratively. We already saw an example for such dependencies with our isLoading state, though for now we just solved, we did not solve this declaratively, but we already had this. So let's generalize this concept to sources and consumers. So consumers depend on their sources, but not the other way around. But of course, a consumer could again be a source for another consumer. As values can change over time, we need somehow to propagate these changes to their dependencies. And this means a change in a source must automatically lead to changes in our consumers. And with that, well, you might have waited for it. I think there is no single talk about reactivity where you do not see some kind of Excel example. But that's just because it's such a good example. So Excel is a good example for a declaratively defined dependency. So here you can see we have a column A and B, both have a value, and the column C, which should be the sum of these values, is defined declaratively as being the first cell plus the second cell. There's actually no other way but defining this declaratively. We have to tell Excel what column C is. So this is an analogy to declarative coding. Now, what would be the analogy in Excel to imperative coding? It would likely be something like this. And if we look at this, in case of Excel, this might look a little bit funny, but actually this kind of programming is what you will find in almost every larger code base. Even worse, often you will find this pattern without the friendly comment that reminds you that you also have to update something that depends. So coming back to our sources and consumers, consumers know their sources, but not the other way around. I already told you this. This is coming clearly from the dependency graph that's giving us this. And with this direction, it's clear that for propagating the changes, in the end, we need some kind of the observable pattern. And as we are speaking of the observable pattern, in case of Angular, using RxJS is the natural choice for this. So in translated to RxJS terms, we have observables and we have subscribers. And well, of course, these could also be observables again via pipes. We will see this. And therefore, they can be observables for other subscribers depending on them. But Before I go on with this, some more definition work. Don't worry, I will make this quick, but it's important for the terms I will use for the rest of this talk. Often people are a little bit confused about the difference between reactive programming and functional reactive programming. So actually, sometimes they're not even sure if there is a difference. The original definition of functional reactive programming was something with so-called behaviors, which were signals over continuous time. You can understand this as simple functions of time that are always resulting in a value. And such behavior can depend on other behaviors and or events. So events in functional reactive programming are signals that occur at discrete points in time. So these are also functions of time, but in this case, they are not always yielding a value, but they may or may not yield a value depending on the time. And also these events can depend on several conditions, for example, on other signals. In reactive programming, we are no longer talking about continuous time, but discrete time. And the analogy to our FRP behaviors here are streams of values, and to be more precise, streams of values that always have a current value. And these current values, they can change at discrete points in time, but whenever you look at the stream, you will always observe a current value. And also these behaviors, again, can depend on other behaviors and on event streams. So what are these event streams? They are also streams of values, but in this case, they have no current value. Instead, they are publishing values, or you could call them events, to subscribers at discrete points in time. And again, such event streams can depend on other behaviors and also other event streams. In terms of RxJS, behaviors are not completing observables that always have a current value. Examples would be the behavior subject. So here you see where the name is coming from in RxJS, or even some pipes with a starts with and share replay. By the way, I think it's start with and not starts with. And event streams would be observables without a current value. And the example in RxJS here would be subjects. So strictly speaking, using RxJS is not functional reactive programming, but nevertheless, it's still highly functional because your observables are declared in the end by function composition by using pipes. So here comes my second step for refactoring an Angular application to reactivity. And that is to set up some kind of state management. In case you have a bigger project, NGRX is the natural choice here. So it's kind of the Redux version for Angular. Though for a smaller project, I think it's not strictly necessary because it really comes with a lot of extra abstraction. And this is also a reason why I did not use this in this talk. Instead, just for this talk, I prepared a very, very simple implementation of a store. In fact, it's just 55 lines of code. I will just show you the API here. So it has just one method to add a behavior. It has a method to dispatch events. We can get a behavior and we can also get an event stream. That's all that is to know about this at the moment. And that already brings us to the third point for refactoring your Angular app to reactivity. and that is analyze and declare all your dependencies. That means also put them under state management. So, well, we already had this, that we must make our dependencies explicit. So let's just do this. As I said, we are now adding our simple store as a kind of state management. Well, it's not only state management, but we will come to this. And what we need now are 3 behaviors. So our query, our book results, and our loading behavior. And this is how it would look like to do this. So, well, in the end, line 1 is not the important part. As I said, this is just a simple store for this talk. These IDs that you see are just constants that I use for type safety. You will see an example for this also later. But the important part here is that we are also using the store here to get an event stream for the queries, and then we are using a pipe. So using a pipe means we are doing function composition here, and this is the part where the functional part of RxJS really shines. So here you see in our second line, we are using a map operation just to extract the query string from this event object. I told you behavior must always have a current value. Therefore, we ensure this by starting just with the empty thing. Of course, we do not want to notify subscribers if no change did happen. So we can use just this operator. And what we also want to avoid is to run this whole pipe multiple times in case of multiple subscribers. So we can just share the result of the pipe with all the subscribers by using this share replay. And as you can see, this is the really nice thing about function composition. Everything is just a one-liner. You can reason about each of these operators just by their name. In fact, if you are, well, let's say, learning about 10 or 12 of the RxJS operators, you can do almost everything with them. Of course, you can also implement your own ones. But with a small set of these, you can do almost everything. So say, for example, we did not only have our query events as an input, but in addition, we might get a query from the URL parameter. You could simply extend this behavior as shown here in line 2 to 5. So here we merge actually our event with the activated route observable from Angular, and we just have a look in line 3 if there's actually a query in this route, and if there is, then we are reaching this to our second pipe starting in line 9. And here you also see an important concept of the functional programming style. We have pipes inside the first, inside the merge. So we are doing composition of code parts. And then again, we compose these inner parts into an outer part, and we can go on and go on and go on. So we are always composing greater things of smaller things, and these greater things again can be composed to even greater things. So coming to our books behavior. here we just depend on the query. And here in line 2, we are performing debound. So this is what actually got us into trouble with our set timeout. Here in functional programming style, it's declarative and it does not bring us in any trouble. And finally, we have to use a switch map. This is because what we want to do here in this block from line 3 to line 11 is to query our book service. And as our book service is not returning books, but an observable of books, we have to somehow unwrap this. And this is be done with a switch map in this case. And the switch map is ensuring that we always only subscribe to the result of the latest query here. So inside this switch map, if there is no query, we are already finished because we know we do not want to show a result in this case, so we can return. Otherwise, we are performing the query. At this time, there is no subscription at this point here, but we are just piping our result onto our result type. And very important, we always have to catch errors when we are performing side effects like here. And it's highly important that this error catching happens inside the switch map. If we would do this outside of the switch map, so for example, between line 11 and line 12, then we would have handled the error, yes, but our pipe would be broken afterwards. So the subscribers of this behavior would no longer receive any notifications from this behavior. Well, and again, of course, we do not want to ask our book service multiple times in case there are multiple subscribers. So we use share replay again. And also worth mentioning is that this whole thing here is lazy. So our behavior for now is just a pipe. The pipe is not executed until the subscriber explicitly subscribes to it. So as long as no one is interested in the books, even if we get a query as an input, as long as no one is interested in the books, the service will not be asked for books. So finally, we need our loading behavior. We had this as a transient property in our initial version of the code. Now we still have the same dependencies. We know it depends on the results that we currently have. This is this books behavior. And also on the query. So we have to pair these two inputs. And we're doing this by use of combine latest operator in line 1. So this ensures that we always get the most recent pair. And with, sorry, I was a little bit too quick. And with that, in line 7, we simply have to make the check if the current query matches the query that led to result or not. And with that, we know if we are in loading state or not. And just in case you were already wondering where all this reducer stuff is people are talking about so much, I added another behavior to count the number of finished requests. So of course, we do not want to perform requests for empty queries. And we also do not want to count something twice. And finally, there it is, your reducer. It's in line number 5, and it's the first argument to the scan function. So this actually is a reducer. It took the previous state here and the new one, the next one. So our message, in this case, it's just the number 1, and it adds them up. And this gives us counting behavior. And this brings me to the fourth step for refactoring Angular application, and this is to use your store as a single source of truth in components. So the only dependency injection that you should do in your components is the store. So let's just do this for our book search component. So before we had this query books and loading as properties. Now it's being observables, and now they are assigned just one time in the constructor. So actually now we are just declaring what they are here one time, and the observables themselves will never change. It's just the data in the stream that is changing. So in addition, I added this finished request behavior, just that you see the difference in the code. And what we have to do now is we have somehow to subscribe to these behaviors to get the actual values. And such a subscription is, you should never do it inside your code, but you should always use this async pipe like shown in line 4, 6, 9, and 10. Because if you would do it in the code, then you would also be concerned to unsubscribe, and you would still have the problem that you have to trigger your change detection manually, because all this are things that the async pipe is taking care of automatically. So you don't have to worry about it. But even more important is you should never have a manual subscribe in the code, because again, like with a set timeout, a subscribe clearly means one thing. A subscribe always means that you want to perform some side effect, because you cannot do something else from a subscribe block. And this fact alone makes it a code smell. So what remains is our event handler. This is now in the end just an event transform. So from the query event to our store query event that we want to dispatch. A further improvement for the whole store would be to have some method at event source, so that we could directly connect our store with the event source. And this would mean that we no longer need a dispatch at all, because also calling this dispatch function in the end is a side effect that we could avoid by setting up the connection one time in the constructor. So let's have a look if this works. I'm typing, and I see I have one finished request. That is because I was typing fast. If I'm typing slow, it's counting correctly. If I'm doing something fast again, it's doing nothing, because now with the empty search, so it seems to work. Let's go on. And I already told you this. My fifth point for refactoring your Angular app to reactivity would be get rid of each and every subscribe inside your components. As I said, the only reason to subscribe manually is to perform imperative code. And this means to perform side effects. And this is breaking reactivity. As long as you can, keep working with pipes, keep connecting things through the pipes. Only at the very end, where you really need the values, and in most cases, this is inside your HTML, there you should look at the values and at no other points in your code. Well, and furthermore, you no longer need to think about things like unsubscribing or triggering change detection. However, it's not always that straightforward as in our easy example. And it's very easy to fall back to imperative habits. So to most Angular developers, code like shown here should look familiar. Well, we certainly have a some kind of edit component where we have a form. So we inject the form builder, and we call form builder group to get a form group instance. And then we subscribe to value changes from this, and we subscribe to status changes from this. And refactoring this into something really reactive is not that trivial as the example before. But just to show you that it's also not that hard, let's assume something like this. So in line 10, for example, we have our form group, but again, we have it as an observable, and we are getting it from the store. So we have some kind of edit book behavior, and I have shown you above. A model could, for example, look like this. So this is not something production ready. You would have to put some more thought into this. It's just to show you that even here, it is possible to separate these things and to only work on the observables. Our edit book model, it could always contain the form group that we need. It could contain a method, a model of your book that you are editing that is always up to date. And it could also contain the information if the current model is valid. And in line 6 to 8, you now also see an example for such an ID. As I said, it's just a constant. Basically here, it's just a symbol making the IDs unique. So even if you have the same name, like in line 7, it would always be unique. And the whole trick here is that by making it a type identifier of a certain type, thereby your get behavior method in line 10 knows what kind of observable, so what type of observable you get, so you have the type safety inside your pipe and code completion and so on. Yeah, so as I said, a little bit more would be necessary to do this. But in the end, it is really possible. So it is really possible to achieve the goal that in all your components in your application, you only inject the store and nothing else. So all your smart components should only inject the store. And yeah, abstraction can be complicated. It could be even more complicated than this example. But if it is, this is the best sign that it's also necessary. Because if abstraction is complicated, this is a sign that the complexity of your code is too high. So there where it is the hardest, there you should actually do it. So, and as I was already speaking about side effects here and there, we still have a conceptual problem with these things I set up so far in our trivial example, because our books behavior, as I defined it now, it's actually performing a side effect upon subscription, because as soon as someone subscribes to this, it's executing a call to the books service. And this, of course, means as our loading behavior depends on the books behavior, that also subscribing to our loading behavior is performing side effect. And this actually is not a good thing. Let me come back to point 2 in the steps for refactoring an Angular application. Well, the original version was set up state management. Actually, it should be set up effects management, because state is just one possible effect, but we should isolate all effects as best as possible. And NGRX, for example, is also doing this very good. It's taking care that if you do it right, you are performing your side effects always just in dedicated effects, and the execution of these effects is done in the store. So the store should be the point where these side effects are actually executed. And if we would rebuild our own simple store, this could look something like this. Should already feel a little bit familiar with NGRX. So we would have book search effect that is actually performing the effect. It would listen to the queries, and it would then register itself to the store, and the store actually would then execute the effect, and with the result it would send a book's result event that then goes into the book's behavior. So the key part here would be that the store is the one that actually is applying the side effect. So now I was talking also a little bit about side effects, and we're close to the end. Well, programming without side effects is actually the best part about functional programming. On the other hand, it's also the hardest part to perform programming without side effects, because it's requiring a shift in mindset. So in the past 10 years, I think things like reactive programming and Redux-like systems and so on, they have done a lot to increase classical object-oriented developers' consciousness about pure functions and side effects. So that's a good thing. This is something where we are, I think, really making progress to go more functional. And especially the shift in the mindset to declarative programming helps a lot in getting started with pure functional programming. I just want to spend some words, especially on pure functions in the end. Well, there is a lot more about pure functions. So it has many, many advantages. But the most important ones during the development process are that they cannot have any side effects and that you don't need to mock them. Let me give a simple example. If you are a new developer and you are thrown on an application where you have functions, so each of these circles here should be a function, and you see the dependencies of these functions, and you should, for example, change something in the marked function on the top. If you know for sure that it's a pure function, then you can be sure that you do not break anything as long as your function returns correct output for the specified input. You also know it cannot throw, so you also need no error handling. And you also know that you do not need to mock anything. If you're not sure that it's a pure function, well, then you have to do the whole work and go down to the button and check each and every dependency in this chain if there's anywhere a side effect. And they are not always easy to spot. So this actually means a lot of work. If you have to spend this work and you find out that there is actually a side effect at the very button, so the red one at the end with the black border. Well, then again, each function in this chain must mock its successor in unit testing. Your unit tests also become much more meaningless. You would need integration tests for everything. And well, you don't have to worry in a purely functional programming language. But unfortunately, in almost every other programming language, you don't have the feature, and this is something I'm really missing. You don't have the feature that you can just mark your function as being pure and have the compiler telling you, well, that's true or it's not true. I'm pretty sure this is something that is not possible with TypeScript because it would need static typing, and this is just optional in TypeScript. But also the big players that are advertising functional programming, like F# and Scala, for example, they do not have this. Actually, I know of only 2 languages that currently have this feature, and that's NIM and the D language. So in NIM, it's the no side effects pragma, and in D, it's the pure keyword. So these languages would throw you compiler errors if your mark a function is pure and it is not. But I know of no other. And as long as you are not going with a purely functional language, but you are using a multi-paradigm language, this would be one of the most important features for me, having the compiler telling me this. And unfortunately, people are not really thinking that way for some reason. This is just one example that I took from a mailing list for the Golang. There were 2 different comments, but you find a lot similar ones. The compiler can already tell whether a function is pure, so I don't think that adding a keyword would lead to any better optimization. Well, they are only thinking about optimization. And the second one, you didn't really explain what we would gain by adding this to the language. It's clearly already possible to write pure functions. How does this help to add the ability to explicitly mark a function as pure? Well, I'm not really sure why people are not seeing the benefit here. So for me, having the compiler to ensure me that using a function does not accidentally erase my whole hard disk or do whatever in addition to its main effect, it would be really beneficial. But yeah, if you know of other languages that can do this, please let me know. Well, but I'm already gone a little bit off topic, and that would also be the end of the talk, actually, and open for questions. Thank you.
All right. Thank you very much, Garrett, for the... You're still on mute, yeah. Thanks very much for the great talk, Garrett. I was wondering, you mentioned the declarative mindset. How would you train, or what are the tricks, some tips for people that want to get a more declarative
one
mindset?
Tip would be never stop abstracting. So in the end, well, we're doing abstraction all day as a programmer. We see some duplicated code, for example, so we abstract it away into a single function. Whenever you take abstraction to the extreme, you always end up with something declarative. Maybe it also helps not only to think about programming, but think, for example, like a team leader. The key in declarative thinking is that you are just telling, well, your program or other people what you want and not how they have to do it. If you are a team leader, for example, and you tell everyone in your team, well, you do this like this and this and this and this, and then you go to the next one, you do it like this and this and this and this. This simply does not scale. It may be, if you're a clever person, it may work out with 3 guys under you, but not more. And there's always the guy that is on top of you and someone that is on top of him, and so on and so on. In the end, it's again, this whole thing functional programming is about, it's composing small part to something greater. Take these something greaters and again compose them to something greater, and so on and so on and so on. That's what I mean by never stop abstracting. If you think you have a good abstraction, think a second time, and I'm sure you can do more. And that, on the same way as I told you, it also makes you a better leader if you are a team leader or project leader or whatever.
Maybe towards Fabio, because I know you're a Scala developer. What's your opinion on having a pure keyword to let the compiler tell you, that your function is not pure while you want it to be?
Yeah, I have seen. Yeah, it's a funny one. I have seen plenty of discussions around it, especially in the Scala world. Like Herd mentioned it at the end. You would expect it in Scala,
I
right?
would.
Because it's such a language that is geared towards functional. Yet, for some reason, this pure keyword doesn't exist there. And I've seen a lot of discussion about it, and I think some of the objections I have said, or maybe like obstacles, was that it would be it wouldn't be deterministic, or that it would be very difficult. I don't know, something from the Scala maintainers. I think it would be really cool.
It is a very hard thing to solve from the compiler point of view, yes. But it would even be a first step. Well, it might be that there are false negatives, so that the compiler ends up in a situation where it cannot determine if it's pure. But then it would be okay for me that the compiler says, well, I do not know, so I say it's impure. But if at least some of my functions can be ensured to be pure, that would give these multi-paradigm languages a lot, I think, because this really is the big selling point of purely functional programming languages. You can have no errors. Well, logical errors, of course, but not errors in the way like we know them from our other languages. And it would really be a breaking thing for me. So I would immediately switch to such a language if I could use at some point still my old habits. So let's say not handling side effects only by the runtime, but if I really know what I'm doing, also performing it somewhere else. But in addition, have the safety of the purely functional programming at all other parts, it would really be a big thing for me.
Yeah. No, I totally agree.
By the way, I should mention, well, if you followed my talk, you might have an idea that I'm not really, not really a big fan of Angular. So it's not really my preferred language, but well, it's used everywhere. But even with TypeScript, you can get very extreme with eliminating side effects completely to the runtime. So if you look at things like, for example, CycleJS, I think it's also very close to the Elm idea, but it's pure JavaScript, and it also handles side effects completely in the runtime framework. But always without the insurance that everything is pure. So always just by convention, and that's the critical point.
It's now that you mentioned Angular, it's also an interesting choice of the Angular team that on push is not the default, right?
Yeah. I think I always think it should be the default. I think if I was responsible for Angular development, I would also not make it default. Well, with respect to backwards compatibility, you would break a lot of big applications.
Yeah.
But I really stay with my point that this is the first thing you should do when you get thrown on a new Angular application. Before you start doing anything else, set everything to on push and see if things keep working, and if not, start refactoring.
All right. And with that great advice, I think we can round it up here. I would like to thank Gerrit a lot for it's a really great talk. Quite enjoyed it. I want to thank everybody thank everybody for joining us. And yeah, make sure to subscribe or enroll into the Reactive Amsterdam community and software development at the Desto NL community for more talks on interesting topics in the future. All right.
Yep. Thanks, everybody.
Okay. Goodbye.
See you soon.
Thanks. Have a nice day.
Bye.